In this question, we have been given a pKa, that's this one here, and a pH of 1.94, and we are now required to make up a buffer. So first of all, we can say since the pH is larger than the pKa, we know that we need more base. Need more base concentration. So that's quite important information, because that helps us to do some kind of reality check. So we can write the Henderson-Hasselbalch equation. So pH equals pKa minus log of the acid concentration over the concentration of the base. And in the first step, we just simply calculate what our acid to base ratio is. So we bring that to this side, we bring the pH to this side, we get log acid, and I just abbreviate it like that, log acid over base equals pKa minus pH, and we just plug in the numbers. So we have pKa of 1.24 minus 1.94, and that gives us a value of negative 0.7. So in order to calculate log acid over base, we just take both sides 10 to the power of, and we get concentration of acid over concentration of base equals 10 to the power of negative 0.7, and that gives us 0.2. So that's the ratio. And we now need to take into consideration the capacity of the buffer, and here we can basically use two different ways, and I'll show you both ways. So in the first place, we can say that let's see what's going on here. We can say that our acid plus the base concentration equals 300 millimolar, we know that. And we need to make up 200 milliliter of this buffer, so that's set in here. So we can calculate how many moles, so how many moles are in 300 millimolar of the buffer. So we're looking for moles. So here we have 300 times 10 to the minus 3 mole per liter. So the mole is in the right place, we just have to get rid of the liter, times 200 times 10 to the minus 3 liter, and we see the liter cancel out, and that gives us basically the same as 0.3 times 0.2 moles, and that is the same as 0.06 mole, which of course is the same as 60 millimole. And now we need to use this information to find out A and B, and we set up there here at this point. That A over B is 0.2. So we have A over B equals 0.2. We know that A plus B equals 60 millimole. So all we need to do is we can calculate A here. So A equals 0.2 times B. And we put that in here. So we have 0.2 times B plus B equals 60 millimole. That gives us 1.2 times B equals 60 millimole, and therefore B equals 50 millimole, or 60 over 1.2 millimole. And sorry, it's 250. 60 divided by 1.2, no, it's 50 millimole, sorry. And A equals 60 minus 50 millimole equals 10 millimole. So if we put A and B together, we get 60 millimole, and the ratio of B over A is 50 to 10, or A over B is 10 over 50. So that indicates that we are all right. So what we now need to find out is how many grams of base is equivalent to equivalent to 50 millimole, and we have our molecular weight of the base up here. So here the molecular weight is 210.65 grams per mole. So we need to find out gram is 210.65 gram per mole, and we have 50 millimole times 50 times 10 to the minus 3 mole. So the mole cancel out, we have gram left, and all we need to do in this case is multiply it. So here we get equals 10.53 gram of base. And we can do the same thing for the acid. So how many grams of acid in 10 millimole? And again, we do dimensional analysis. Gram equals, we have 195.45 gram per mole, and we have 10 times 10 to the minus 3 mole. Mole cancel out. So that gives us 1.95 grams of acid. Now, a slightly different approach, but which leads us to exactly the same number, is we can calculate our acid over base ratio. That's again acid over base equals 0.2, and we said that acid plus base gives us 300 millimolar. Now we can calculate our acid concentration. That is 0.2 times base concentration. We put that in here. And now what we do here is we can say this gives us 0.2 base plus base equals 300 millimolar. This of course gives us 1.2 times base equals 300 millimolar, or the base concentration equals 300 millimolar divided by 1.2 equals 250 millimolar, and the acid concentration equals 300 millimolar minus 250 millimolar, and that is 50 millimolar. So our job now is to make up 200 milliliter of a 250 millimolar base. And again, we can do that with dimensional analysis. Gram equals 210.65 gram per mole times 250 times 10 to the minus 3 mole per liter times 200 times 10 to the minus 3 liter. The units cancel out apart from the grams, and what we get here is, if we multiply that all with each other, then we get 10.53 gram of base. And we can also do that for our acids. So here our task is 200 milliliter of 50 millimolar acid. And we use dimensional analysis. So gram, we have 195.45 gram per mole times 50 times 10 to the minus 3 mole per liter times 200 times 10 to the minus 3 liter. Liter cancel out, mole cancel out, and we end up with 1.95 gram of acid. So both methods are absolutely equivalent. They give the same results. In the one case, we just first calculate how many moles does the buffer have, or we can also calculate what is the concentrations of the different compounds. So here the 250 and the 50 millimolar, but the result is equivalent. It always comes to the same conclusion.